Alright, in this video we are going to check out what is a composition of isometry. So those are some fancy words, but we're going to break it down. So the first thing is, what in the world is a isometry? And then we're going to look at this, what is a composition? Then if you look over here, we're going to ask two weird questions. So if you do two reflections over parallel lines, what in the world happens to that figure? And then, if you have two reflections over intersecting lines, what happens to that figure? Okay, so some magical stuff happens. Let's check it out. So first of all, what in the world is an isometry? That's a fancy word, but here's how you would break it down. It's basically just a transformation, which you guys have been learning. A transformation is just any type of translation, rotation, reflection, or dilation of some pre-image. But an isometry preserves distance or length, or and length, right? So it's basically a rigid motion. Okay, so here's some examples of isometries. You have the translation. The R doesn't change when it moves from one spot to the next, so that's definitely isometry. Rotations, the R is not changing, so that's A-OK. And then look at the third one, reflection. It's just flipping over the line. So even though it's facing a different way, it's still an isometry. And then this one's the rebel. This one's the one that doesn't work. So if the R is expanding, getting bigger or smaller, then it's not an isometry. So dilations are not isometries. All right. So then the big part of this section is, listen to this point, is that a composition of isometry. So a composition of rigid motions. How do you do that? What does that look like? Can you do it? I think you can. So check it out. So it's basically when you have two or more isometries combined. Okay, so you guys have been doing one transformation, one isometry. So now we're just going to combine two or more together. It's not that bad. Here's the big thing that you need to know, though, is that this is kind of backwards when you read it. So what you want to do is start with the innermost one first. So this is the reflection of M with the composition of the reflection over line N. So this is the one you start with first. Reflection over line N. That's the first one of triangle ABC. Now look over here, guys. So we got the line N and we got ABC. That is that first one right there. We're reflecting that figure over line N and creating ABC prime, okay? Then first step is done. So that one is okay. Then in the composition, you go to this one now. So that's the second one that you're going to do. Reflection over line M. So here's line M, and we're taking ABC from the first reflection, bam, over that line, creating ABC double prime. Okay, so that's what a composition transformation looks like, and that's how you do it. This one first, that one second. Now let's check out the next concept. So we got two specific situations for you guys to remember, to understand, to check out. So look at this one. We got two reflections over parallel lines, and then here's the spoiler alert. That's going to equal a single translation. So look at this. We have two reflections over line N and M of ABC. So bam, and then bam. Okay, here's what you need to zoom in on. So we got ABC. Notice how it's just basically a translation. So two reflections equals a translation. They are the same thing. Okay, so that's the big idea there. Now the next thing that you guys are going to need to know for, say, your unit test is what's the distance between this double reflection or this translation if you knew this distance. So if you know the distance between the two parallel lines, in this particular example, if you look here, it is 12. Then the trick, the answer, is that the distance between these two figures will always be 2 times that distance. So in this case, it's 24. Now let me throw a little pop quiz at you. What if this number was 9? What would the distance between these two figures be? And 18, yeah. So there's always twice the distance. If you know this number, then just divide by 2 to get that number. All right, last concept, check this out. So if you have two reflections over, instead of parallel lines, we got intersecting lines. What does that create? Well, spoiler alert, it is a rotation. Okay, what in the world does this mean? So basically, look right here. So you got two rotations over line N and, or reflection, sorry, misspoke, over line N and M. So bam, and then bam, right? So notice how this pre-image reflected twice over two intersecting lines is the same thing as just taking the figure and going and rotating it. They are the same exact thing. Okay, so the last trick that you guys need to know is that how to find this angle of rotation right there, right? So the trick here is that it's just, if you know the angle between these two intersecting lines, like this one's 60, then the full rotation angle will always just be 2 times this inner angle. And that's it. So like if this is, say this angle was 30, bam, you know that this angle would be 60, right? Okay. So that's this section. If you guys have any questions, make sure to ask your teacher, and I'll see you guys in the next section.